So next one is now dosage based on the size of the patient. So a lot of time the weight of a patient must be considered to properly help the patient, obviously, right? The size of the patient is measured by body surface area, or in other words, BSA for short. So body surface area. Now, the best way I can think of what it means by body surface area is if, it's kind of morbid, but if we literally take our entire skin out and we sit on a flat surface, that is called the area, right? So we do length times width. So that's the body. What do we mean by the body surface area? It's the entire area of our entire skin. So that's what it comes to. So since it covers our entire body, hence why it's called body surface area. Okay, so that's what that really pretty much stands for there. Okay, now when it comes to this is going to be the very most important equation when it comes to surface is always going to be the size of the patient times the order will always give you the dosage which you're actually going to be administering. Okay, so size of patient will be, the BSA. The order will be given to you, what the actual order the doctor gives you. And once you multiply them, that will give you the dosage you're going to give the patient. That's the most important thing. Okay. Now, if the patient size is considered, then we're always going to be using in kilograms. So the weight will always be considered in kilograms. Okay. So let's try for example 10 so you can see what this is actually going to be processing. Okay. So number 10 says, if a patient must take 15 grams per kilogram. So what this is saying is, no matter how many kilograms you weigh, you're taking 15 per kilogram. So let's just do it, in our case. So let's suppose you weigh 5 pounds and you have to take 5 liters every pound. So that means you'd be doing, 5 liters for every pound you take. So 5 times 5 gives you 25. So you're taking 25 liters of that. So that's what this represents here. Okay. So that means the patient must take, so I say 15 grams per kilogram the patient weighs. Okay. So essentially that portion. Now, I kind of cut it off here. So for every kilogram, let's base it. So let's suppose the patient weighs, 85 kilograms, for instance. Now, how much would this patient take in this instance? So he gave you guys a scenario how we can actually use this. Okay. So first, size of the patient. So that's the weight of the patient times the order. The order is 15 grams per kilogram. Now notice, it's about the same, right? We really want to cancel out kilograms, but it's easier to, go by an equation when it comes to it. So once you multiply, this can be 1,275 grams. So you would administer that kind of much for his dosage. Okay. So now let's go to example 11. So this patient orders 0.75 milligrams per kilogram of a drug. So this is the order, right? Hence why it says order. If the patient is, so if the drug is 200 milligrams per 5 kilograms, how many milliliters of the drug should be given if the patient weighs 154 pounds? Okay, so a lot of information to get. So what in the world does this give us, right? And now what is this? Now, in order to use our equation, right, it's size of patient times order equals dosage. Now the size is always expressed in kilograms. So the first thing we have to do is convert the pounds into kilograms. So we know there's 150 pounds, and so now, just like your quiz, right, from chapter 5, there's 2.2 pounds for every 1 kilogram. So once we divide this over, this should give you exactly 70 kilograms. Okay. Now, let's start from here. So we go 70 kilograms, okay, times, now we can talk about the order of the page. So the order itself was 2 things, right? So we're given these 2 things. So the first thing we do is, what do we get cancel out kilograms? So that's the order. So this is 7.5 milligrams per kilogram. Now remember, the goal in this is to get milliliters, right? That's our goal. That's what we want. Now notice, if we cancel these units out, we do not get milliliters, we get milligrams. That's when we use the other type of the drug. Okay, so this one says for every 250 milligrams, there are 5 milliliters. So these cancel. Now, you're wondering, okay, why is this a lot of information? Well, this is essentially the same portion. This is size of the patient, and this is still the order of the portion. So that whole thing is still the order. So we're still actually doing size times order, and it gives you the dosage itself. So once we do all of this manipulation, we only get milliliters, and we only should get 10.5 after all that multiplying and dividing after that. Okay. So like I said, right, in the comments, right, I send you guys an email. If you guys are having trouble, make sure you guys talk to each other, when it comes to this class. It gets a little bit more complicated, just straightforward, conversion and stuff. Okay. All right, so now let's do 12 in the back. Okay. So a physician ordered 13 milligrams per kilogram of a drug. How many tablets of the drug should be given to the patient if the patient weighs 180 pounds? Now, this is almost identically like number 11, which is, the best part. They might not, look alike, but it's the same template as it is, right? We're given the order and also given the equivalency for the drug itself, right? 40 milligrams per one tablet. And since we want tablets, that's going to be our nice conversion to deal with. So just like the last one, we have to first convert pounds into kilograms. So dividing this out should give us 81.82 kilograms. Okay. And now we just start from there. So 81.82 kilograms times now the order. So the order itself was 13 milligrams per kilogram. So 13 milligrams per kilogram. Now again, right, that does not give us tablets. That's when we use the label itself. So the label tells us it's 40 milligrams per one tablet. So therefore, since these cancel, we know there's 40 milligrams for every one tablet. Those cancel, and after multiplying and dividing, so again, same process like I said before, size times order gives us the dosage, which means the dosage in this case should be 26.6 tablets. Okay. So the last thing about this section is actually finding the body surface area. Okay, that's one of the major things. So this is just, the size of the patient in kilograms. But what if, it's a little different, right, when it comes to it? So the reason why we care about body surface formulas and surface areas is, well, these are most important when it comes to the, out of the norm kind of stuff, okay? So, for example, kids is a huge portion when it comes to size of a patient, right? A 5-year-old is different from the weight of another 5-year-old, etc., like that. So we have kids, cancer therapy, burn victims, and critical values because, again, right, just weight doesn't give you alone. You also have the actual size, is he skinny, large, things like that, right? So, okay. So when it comes to BSA, the units are always going to be in m squared, meters squared. So, right, area is always in something squared, n squared, x squared. So it's in meters squared, okay? Now, here's the thing. There's two actually different formulas for these, okay? One is the metric one, and one is the household one. So the BSA for the metric is weight in kilograms, height in centimeters divided by 3,600, all inside the square root. Okay. For household, it's going to be in pounds, height in inches, and this one actually has to cross out. This is the wrong one. This should be 3,131. Okay. So just go ahead and cross that out. It should be 3,131 for household. Okay. So now I'm not going to trick you guys when it comes to it. I will give you both of these or both of those. I'm not going to give one or the other, and you have to choose which one it comes to it. Okay, so it's going to be pretty straightforward. So, for example, let's actually try 13 so you can see how to use these formulas. Okay, so the order was 15 milligrams. So I don't know why Word does this. It's supposed to be m squared of a drug. How many milligrams? So this is what we want. How many milligrams of a drug would be given to a patient that weighs 90 kilograms and a height of 150 centimeters? So here's our order. Now it's the same process, right? Size times order should give you the dosage you're given to us. Now here's the problem. Because it's an m squared, right, we can't just multiply by that. We have to find the BSA first to cancel out the m squared. So first thing we have to do is find the BSA for this patient. And since we're given kilograms and centimeters, we're going to be using the BSA for the metric system. In other words, this equation here. Okay? So for the BSA for the metric, it's going to be 90 times 150 divided by 3,600, all inside the square root. Okay? So I'm going to give you guys a quick minute just to quickly break this down. So multiply these two, right? Then divide it. Then finally take the square root, right? So just go ahead and pause it. And hopefully you guys got roughly 1.93-ish, approximately. Okay, if you're off by a little bit, no worries, just how to rounding when it comes to it. So that's your BSA, again, in meters squared. So now since we have the size of the patient, now it goes on to the formula. It is size times the order. And order is 500 milligrams per m squared. So these cancel, and we get milligrams, right? The dosage we're actually going to give them. So this should give you 96.8 milligrams. Okay. And that's how we use BSA to do it. Okay. All right, so let's just do the last two examples. I'm about at the 11-minute marker, but 2 more examples shouldn't take too long to deal with. Okay. So let's do 14. So actually, why don't you guys try 13, 14. One little change for 14. Again, it should be m squared. Okay. So go ahead and try, pause it, 3, 2, 1, pause. Okay, so hopefully you guys did it. Now let's do this together. All right, so example 14 says the order was 30 milligrams a meter squared for a drug to a patient who has a BSA. So great, good job, right? I mean, you gave half the work. You already calculated BSA for you. The safe dosage range for this drug is 25 to 45 milligrams per day. This is interesting. Different problem. Calculate the dosage in milligrams and determine if it is within the safe range. Okay, so there's 2 different questions here. Let's just do the first one. So we're given the order, we're given the size, and we want milligrams. So which means size times order should give us exactly what we want. So the size of the patient is 1.75 m squared times the order, which is 30 milligrams over meter squared. So this should give us 52.5 milligrams. Okay, so that's the first part of this question. Okay. Now let's look at the second part. So the second part says, and determine if this is within the safe range. Okay, now it says the safe range is anything between 25 to 45 milligrams. So let's look over here. Is this between 25 and 45? Hopefully you say no, correct? So therefore it will be not in the range, so not safe. Okay. And there we go. That's how we do these type of problems. Okay. So last one for this this chapter, 15. So order is 10 milligrams per meter squared PO per 6 hours. So that's going to be a key thing. Every 6 hours. Okay. Until the sermon methotrexate level is less than. Okay. The strength of this one is 15 milligrams per tablet. So they give us a lot of information, right? It's 15 per tablet. Calculate how many tablets, so we're talking, that's what we want, would you give a patient who has a BSA of 101.49 meters squared. Okay, so here's the size, here's the order. Okay, let's see what we get. So size of the patient, so 1.49 meters squared, times the order, 10 milligrams over m squared. Now, right, just like we noticed last times, we don't want milligrams, we want tablets. That's what we use in the next conversion here. So this is, again, still size. And the combination of all this is going to be the order, which is now 15 milligrams per tablet, which gives us the dosage. So how many tablets should be, I believe, exactly 1, if I'm not mistaken. Oh, pretty much about 1. It's like 0.996 or something like that, so we'll just round to 1. Okay. All right, so that finishes up chapter 6. So oral medication.